Good evening. Welcome to the Wednesday night update on the Tropics. As always, these thoughts are mine alone, and in making decisions regarding our three systems we have here, Douglas, 91L, and Gonzalo, all respectively. Please refer to the National Hurricane Center, your local National Weather Service office, and your local officials. We're going to be talking about Douglas here first, then we're going to talk about 91L, and then we're going to talk about Gonzalo here. All of which are threatening land and all of which deserve to be talked about. I'm not a meteorologist. Please refer to officials when making decisions. So let's get into Douglas first. So Douglas, this is a visible shot of Hurricane Douglas here. This storm has undergone a robust period of intensification. This is likely not the 80-mile-per-hour hurricane that the National Hurricane Center pinned this at several hours ago. And this storm's eye has been warming all day, and you can see that the cirrus no longer really obscures the eye as much as it did, and you can see continued very violent convective bursts that are firing around the eye wall and will likely symmetrize and make the storm look prettier on satellite imagery, essentially. This is still 4+ days out from impacting any area. However, this enhanced period of strengthening likely means that Hawaii will be getting effects that are far greater than what might, or are greater than what is currently forecast. If you look at the National Hurricane Center forecast, you can see that they expect this to become a major hurricane at some point within the next 24 to 36 hours. After this, it crosses a thermal gradient in the sea surface temperatures right around here, and will begin to gradually weaken on approach to Hawaii. This will not be looking like this when it is on its way to Hawaii, so this will not be as strong, but it will still be probably strong here and maybe a hurricane, according to the National Hurricane Center. So if you are in Hawaii, please refer to the National Weather Service in Honolulu for the latest regarding your area and your specific island as to what to do with tropical or Hurricane Douglas. All right, now let's get into 91L. Speeding through this. Today, 91L had a recon mission that went into it and found a broad circulation in here that is elongated from east to west. You can see there are winds coming out of the east on the northern side and winds that are generally kind of moving towards out of the west on the southern side, and you kind of have a very disorganized convective pattern in here. This is not very well done, and this is not enough to classify it. If you look at the recon mission, they found winds out of the east on the northern flank of the general circulation and winds out of the west. These are not very strong winds. This is 10 to 15 knot winds, really. This is not strong at all. And is going to take some time before this really consolidates. We're going to look at the divide between the European model and the GFS model here. So this is the European model come Thursday around lunchtime. And this has a still broad system here, but it is consolidated enough to where it can kind of gradually intensify. The European model brings this up to the Texas coast come day 2. Come Friday, it is a more circular system and is actually deeper than the GFS here come Saturday, and then come Sunday, it is ashore here. What the difference is between the GFS and the European model is that the European model has a stronger system that feels the upper levels of the atmosphere, which in turn slow down the storm because the steering in the upper levels of the atmosphere collapse, and the lower levels are still pretty strong. But if it is a taller storm with height, then obviously it will become top heavy and not be able to be pushed as easily by the lower level winds, and will be pushed by all levels of the atmosphere. This is not a storm that storms are not pushed by a single layer or a single steering layer. This is all layers of the atmosphere. The difference between this and the GFS model is that the GFS model at around the same time has a strung out circulation here that is very elliptical and is less consolidated than the European model, and you can see that it's just very strung out, and this kind of keeps the GFS model keeps it this way, and it remains very elliptical and very loose and not very strong, which in turn, due to the lower level weight of this storm, so to speak, it's more weighted in the lower levels, I should say. The storm is not able to really intensify much and is pushed ashore too fast, and really is just kind of a glorified tropical wave that comes in here and provides a lot of rain for the southern 2/3 of Texas before dissipating inland. And so what we really need to watch here is how quickly the storm can consolidate over the next 24 hours. Bottom line, if you are in Texas, or especially on the south central Texas coastline here, stretching from the Matagorda Bay all the way south of Corpus Christi near Kingsville, you need to be preparing for what might be a tropical storm. Again, this is not expected to become particularly strong over these waters, and the storm will not be able to really intensify too much, as it is going to remain broad for the majority of its life regardless. And really, at maximum, it will probably have only like 2 days to really intensify, which does not give it that much time, especially since it is still probably going to be broad during all that time. But regardless, if you are on the upper Texas coastline here, in Houston and Galveston and Port Arthur and parts of Louisiana, need to be watching for rainfall, enhanced rainfall, and maybe rip currents along this kind of stretch of coastline here to the north of the system, as this will be bringing rip currents and higher surf to these areas, maybe some minor water rises here. But overall, impacts are not expected to be too severe. This is not going to become a hurricane, I don't think. It definitely does not have the time to do that. And bottom line, this is just going to be kind of some rough weather here come this weekend. Okay, now let's get into Gonzalo. Gonzalo, seen here on the water vapor imagery, has intensified further than expected at this time, come from yesterday. The National Hurricane Center currently has this at 50 miles per hour and 1,000 millibars. This is a very small storm here and is subject to wild changes in intensity. This is noted in the National Hurricane Center discussion on the storm, that the intensity forecast is very cloudy. There is a lot of ambiguity with the short-term intensity forecast, which leaves even more ambiguity to the long-term forecast for track and intensity. So, let's get into this. Gonzalo has expanding outflow out of the northern quadrant now. It is kind of between two shear vectors here. You have shear out of the east to the east of the system, and shear out of the general north and west, or west-northwest here, that is to the west of the system. So right now it is in this kind of area where it can intensify with very little impediment. There is not a whole lot of shear that is in this environment, and you can tell that the moisture field here is safely encasing the storm from any dry air. There's dry air immediately to the west of the storm, and there is dry air immediately to the north. There's a little bit of a buffer in here where there is some moist air that is being kind of pushed into the storm, so it's not struggling too much. This has been firing off very high convective tops, cloud tops all day. You can see that here on the infrared imagery. The convection is very cold here, and has been trying to fire around what is a formative eye in the lower levels, and is transitioning to being part of the entire storm structure. And once this does happen, there is a pretty high possibility that this could rapidly intensify. Once that structural problem is fixed, the storm could intensify quickly. These waters are pretty warm, and the environment, as I said earlier, is very moist around it, so it could intensify a lot further than what is currently expected by the global models. a good example of this. It's not the GFS model. We'll get into that in a minute. We're going to get into the H-Wharf model first, and look at the precipitation dynamics here. This intensifies the storm very quickly. This is only 12 hours, and has this storm intensifying into a 978 millibar Category 2 hurricane. While this is a bit extreme, this certainly is possible given the storm's small size. If I click here and show you how large the core of the system is, this is only 40 miles across, and that's generous, 50 miles across. But this is not very large and is not pulling a whole lot of moisture with it, so it is able to tighten up much quicker than a storm that is medium size or large size. So the H-Wharf intensifies this very quickly and keeps this very strong, and actually intensifies this into a Category 3 here, 965 millibars. If you look at the 10-meter winds, this is probably a Category 3 hurricane. Yeah, this is a Category 3 hurricane. And has this very strong on approach to the Leeward Islands, and keeps this very strong all the way on approach, which is very different from the GFS model. We look at the tropical Atlantic region here. We'll have that up in a second. You can see that the GFS model has this into a strong tropical storm. This is not a Category 3 hurricane as expected by the H-Wharf. Keep in mind that the H-Wharf has been better at handling the intensity of this storm. It has not been perfect, but it has been better at handling the intensity. And the GFS model has this maintaining a strong tropical storm intensity all the way through the Leeward Islands and all the way through the Eastern Caribbean, and that is because there have been some changes into the upper dynamics and overall environment surrounding the storm. You can see that the shear has backed off significantly since yesterday's forecast, where there was shear that was practically on top of the storm, and so the storm is able to kind of have a little bit of an environment in here to where it can maintain its intensity. There's shear immediately to the north of it that could also shear off the storm, but that is far enough to the north to where the storm will actually probably be able to use it to ventilate the convection. Again, smaller storms are very hard to predict with intensity, so bear with us. This is something that is going to be hard for all levels of meteorology. The storm, if you take a area average sounding of the storm upon approach to Barbados, you can see that the relative humidity values are very, very high, and the shear is low here. So that is an environment that is very favorable for rapid intensification. And what we're going to be talking about here essentially is if this storm is able to become much stronger than what is currently forecast by the GFS. I'm going to go into the 500 millibar vorticity and show you there are a couple features here that may drag the storm to the north a little bit. You see here you have a vorticity maximum or of some sort, shortwave vorticity maximum here that attempts to drag the storm north. There's a weakness in the mid-level ridge here that is right here. The mid-level ridge generally has flow that is to the west, and this feature kind of rides along with Gonzalo through the Eastern Caribbean, which promotes a more west-northwestward track as seen in the GFS forecast. And this mid-level ridge is able to kind of guide it back to the west once this feature, as you can see, is no longer here or as potent. And so the storm eventually does crash into Hispaniola. This is a problematic forecast because this is still 5 days away, and there is a lot that can be changed. There especially is a lot in the intensity part of the forecast that can be changed, which would mean that the influences on the storm are not as evenly distributed as they are right now. So we could have, if the storm is weaker, then it will be feeling the lower level steering more. But if it is stronger, then it will be feeling the mid-level and upper-level steering just as much as the lower-level steering. And so we're going to have to kind of sample all levels of the atmosphere here. And come around this time, if you look at the steering, oh, well, that didn't work. if you look at the steering to the north here, I'm going to try to get off of Hispaniola here. You have steering in the upper levels in the beyond 300 millibar height. That is out of the north and northeast. And then you have steering in the mid levels that returns to being westward after being out of the being more northwestward, and then you have lower level winds that are also out of the west or out of the east here that are pushing the storm due west. Again, if the storm is stronger, it will feel these upper level flows more, and so it may be a little further to the south and miss Hispaniola. Again, this is still a 5-day forecast, and if you look at the National Hurricane Center forecast, you can see that the GFS is actually on the northern part of this forecast. The H-Wharf model is more on the central part, and again, this will likely be adjusted come 11 p.m. due to changes with each advisory that happen. And the Gonzalo has been kind of riding the northern part of the cone for a little bit here, and so maybe the National Hurricane Center will adjust it. We do not know for sure. And ultimately, they know more than I do, so always listen to them. But they do expect this to become a hurricane in the near term. You can see that here by Thursday afternoon. This storm is a hurricane, according to the National Hurricane Center, and could become a hurricane tonight. Again, smaller storms are really hard to predict. This storm is very small, and they're very fickle, and their changes are significant in every passing moment, so you have to really watch these storms closely. As always, stay tuned to the National Hurricane Center for the latest, and please look at your local National Weather Service offices for all of the latest information regarding Gonzalo, Douglas, and 91L. And stay safe and have a good night.